HSRP authentication allows us to verify those HSRP packets as they're being received by HSRP-enabled routers. And this is important because we only want our routers to be part of the same group if they are authentic. We don't want a rogue router to join that group. So we want to ensure that our routers in the group do not receive any hello packets or accept any hello packets from rogue HSRP routers. So by authenticating, we make sure that our HSRP group remains a tight-knit group of routers that we deem to be authentic and trustworthy. Now, there's two different ways that we can set up authentication. We can do so with a key string, or we can do so with a key chain. So depending on the type of authentication you've implemented will determine how deep you have to go with your troubleshooting. If it's just a key string, you can look in the running configuration and see the key string attached to the standby group authentication command, and you can go ahead and modify those key strings so that way they match between the HSRP routers. However, if you're using key chains, then you're going to have to verify the key chain, and you'll have to verify that the correct key chain has been attached to the authentication. Now, some of the devices are going to support both plain text authentication as well as MD5 authentication, so you'll have to make sure that the type of authentication is accurate as well, making sure that both are using plain text or both are using MD5. Here's an example of HSRP authentication issues. It tells you. Look at that. HSRP, bad authentication from 10.1.1.2. If we go over to DSW2, bad authentication from 10.1.1.1. Wow. We can't miss that, that's for sure. So if we have syslogging turned on, whether it's to the console or whether it's to the VTY lines or to a syslog server, we can double check and verify that authentication is or is not the issue. In this case, it's telling us clearly that authentication is bad. In addition to that, you'll experience multiple active forwarders when you have authentication issues. So here the state is active on DSW2 for group 10. If we go over to DSW1, show standby, the state is active as well. Now, why is the state active for both of them? Because they can't technically see each other. They receive the hello packets and they go, oh, wow, that's not an authentic device. So therefore, I am not going to consider you as part of this group. And if you look down below, the standby router is unknown. If we go to DSW2, we see the same thing. Standby router is unknown. So they're both classifying themselves as active with no other router existing as part of that particular group. So we're being told in a lot of different ways that authentication is the problem. So what type of authentication are we doing? Well, it says right here we're using MD5 authentication, and it is using a key chain of TSHOOT. So we're going to have to troubleshoot the key chain here as well. But let's verify on DSW1 if it's using MD5 and the key chain of TSHOOT. And we can see from the output on DSW1, it is using MD5 authentication with a key chain of TSHOOT. So we've confirmed that it's not a problem with the configuration command for HSRP. If we look at the output of show run interface VLAN 10, we'll see here that standby 10 authentication MD5 keychain TSHOOT was the command that was used. We'll look at the same thing on DSW2 show run interface VLAN 10. We'll see in this output standby 10 authentication MD5 keychain TSHOOT. Let's just copy and paste that over here so we can compare it. It's the same command. So it's not this command that's the problem. It's more than likely our keychain that's the problem. So we can verify the keychain by typing in show keychain. When I look at the output of this keychain, it says the keychain name is TSHOOT. It has a key ID of 1 in this case, and the text is CCNP. Let's go over to DSW2 and type in the same thing, show keychain, and we'll see that it's called TSHOOT. Now, just to be aware that the keychain doesn't have to match. So I could have used a completely different name for the keychain on DSW1 and DSW2, and that would be fine. But it's the material inside the keychain that matters. Key 1 has to match key 1 on DSW1, which it does. Key 1 is the same. The text would have to match as well. In this case, we see CCNP, and we see CCNP. But I want you to pay really close attention. Stare at that text. And let me go back and forth. Do you see a difference there, folks, where it says CCNP? Pay very close attention. Do you see an issue right there? Oh, we had syslog. If you didn't see it, let me point it out to you. There's a space right here. There's a space after the P. That completely throws off the authentication. So there's our problem right there. Let's go ahead and fix that on DSW2. Configure terminal. The key chain is called TSHOOT. The key ID we have the problem with is key 1. And our key string has to be CCNP without a space. Let's go back and verify show key chain. And as you can see, we've already realized, oh, there is an active router out there. So I am going into the speak state. So DSW2 went speak, then it went to standby. And if we look at this key chain, it's fine now because we changed the key string to CCNP. So just that little space in the key string caused our problems in regards to authentication. But authentication has to be perfect. It has to match perfectly if we want the routers to be part of the same group. So now we can verify with show standby that this is fine now. We are standby. We go back to DSW1, show standby. We are active. So keep that in mind. If you ever see 2 active forwarders and you're using authentication, authentication is probably the reason why you have those 2 active forwarders. There's something wrong with that authentication.